start recording. So we have to label our axes. We need the quantity and the unit on each axis. Our x-axis is the independent variable, and our y-axis is the dependent variable. Now, at the top of the graph, and we didn't write it here last day, so maybe you just want to take a look at page 103. What goes at the very top of the graph? The title. And do you remember what goes in the middle of the title? Versus. And it's either going to be x versus y or y versus x. So is it x versus y, or is it y versus x? Tell your partner what you think. When I write my title, it's going to be something versus something. Is it x versus y, or is it y versus x? If you like x versus y, I'm going to show you the letter x, okay? The letter x, you put your fingers like this, and then your pointer finger curls up and your thumb sticks out to the side. That's the letter x. Okay, that's an x. The letter y, I don't know if you guys know the hang loose symbol. Hang loose? Okay, that's the letter y. So this is x with the little curly finger and your thumb sticking out, and then there's y. So which one comes first? X or y? 5, 4, 3, 2, vote. I gotta y. Put up your hand with okay. So I got some y's. That's some y's. It is y. Y comes first. If you have trouble remembering that, which direction do you read? Do you read left to right, or do you read right to left? You may do that, but not in English. Okay, left to right. So distance comes first, and then time. Yes? No. You can refill it at the end of class. So it is distance versus time. Y versus x. And where does the title go? Does it go at the bottom of the graph, at the side of the graph? It goes at the top of the graph. So we'll put distance versus time. Okay, so those are the three things we have so far. We need to label our axes. We need to know that our dependent variable goes on the y and our independent variable goes on the x. And we need to know to write a title, y versus x, not x versus y. Those are the three things we learned last day. And now we're going to learn how to label our axes with the scale. You're going to choose a good scale, which means if this is your axis, would it be better to go 2, 4, 6, 8, 10, or would it be good to go 2, 3, 5, 6, 10? Tell your partner which one of those you like. Do you like option A, or do you like option B? Option A or option B? Option A, indeed. Okay, so this one is good, this one is no good. They have to go up by the same amount. So it's like skip counting. You have to skip count by 2s or by 5s or by 10s or by 4s. Okay? Usually we go up by 1, 2, or 5 or other multiples of those. So a 1 could be going up by 0.1. So you could go 0.01, 0.02, 0.03. That would be if you have really small numbers. You might go up by 2s or you might go up by 20s. You might go up by 50s if you have quite big numbers. Okay? It's really hard if you start going up by intervals of 7. Yes, because it's hard to split 7 in half. It's hard to know where you are in between the 7. So try to stick with things like 1s and 2s and 5s and 10s. Does that make sense? If you have to do a 3, people can usually manage a 3. And 4 is often okay as well, but 7s are weird. 9s, 13s, don't go up by 13s. That's just crazy talk, okay? Always make a scatter plot. So this is grade 9. I'm just telling you right now, unless it is obvious that you should use another type of plot. And we're going to do a POGIL activity tomorrow that shows you when to use scatter plots and when not to. But for the most part, we will do a scatter plot, which is where you have the dots and you draw the trend line. And you already know, do not play connect the dots. Always draw a trend line, okay? And you'll use a ruler for that. Unless it's a curve, I'll show you what to do if we have a curve. And you want to make sure your data is graphed as large as possible so you take up as much space on the page. So if your page is this big, maybe your graph is this big. Okay, it's not going to be like crammed in a little corner. Make your graph small or big? Big. Okay. Here are some examples of good and bad graphs. Here's a bad graph. I would like you to look at it. You can ignore this number 104 here because that's just the page number, okay? Look at this graph and tell me anything that you can find that is wrong with this graph. What is wrong? Chat with your partner about that. What is wrong with this graph? I'll call on you when we get to it, okay? Yeah. You guys must all know because you don't need to discuss with your partner, so I could call on any of you, yeah? Well, I know Lucas wanted to give me one. Lucas? Yeah, they connected the dots. No good. Yes? 0 isn't at 0. Yes? It's not labeled. Anything else? There's one more thing missing, at least. Yes? We need a title. There's no title. Okay, so those are the things that are wrong with this particular graph. The scale looks okay. This is going up by 10, 20, 30, 40, 50. Yeah? This one goes up 0, 40, 80. So those are multiples of 40. That's okay. Are all my points, and all my points aren't crammed down into one corner, so that's good. Okay, they're spread out nicely over the graph, so that's good. So there's no title, there's no labels, there's no units. They played connect the dots. Why is 0 not at 0? And why? Also, why is the graph so small? If you have the option, you would make it much bigger. This is the same graph, but now we have the labels. We've moved the 0 down. I need to move it down even further because it's not quite there yet. I need to fix this. Fix. Okay. And we have a title. Doesn't the clarity and beauty of this graph just make you want to cry? That's okay. All right. Which of these graphs is more correct and why? So we're now on the next page. We are now on page 106. Turn to page 106. Which graph is better, A or B? We will vote on this. So we get to vote either A or B or I don't know yet. Okay? And if you don't know, maybe you should ask your partner. Nobody's asking their partner. Okay, 5, 4, 3, 2, go. Which one's better? A is better. Why is A better than B? Yes. Yeah, the x-axis on B is going up by 2, and then it goes up by 1, and then it goes up by 5, and then 2. So it's inconsistent. So this one is not good. This one is better. Here is a new vocabulary word. Linear. And linear means that it goes in a straight line. So all of the graphs we have done so far have they been linear or not linear? They've been linear. We can draw a straight line. Okay, so we could draw a straight line here. We could even, assuming this was a good graph on the left, on the right, we could draw a straight line there. There are all kinds of different curves, but what you're not going to see is a curve like that. You will not get wiggly-waggly curves. No wiggly-waggly curves. You're going to see a smooth trend. Either it goes up and it goes up faster and it goes up faster and faster and faster. Maybe it goes down slowly and then it goes down faster and it goes down faster and faster and faster. Or maybe it goes up fast and then it starts to go up more slowly. Maybe it goes down fast and then it starts to go down more slowly. And then there's this fun one. This one, if you take Chemistry 12, you will see this graph. This is called you do not need to know the word sigmoidal, but it is called a sigmoidal graph because the sigma is the Greek letter S. And what does that curve look like? It looks like an S. You don't need to know that name though. And this one here is also sigmoidal. It's just not as obvious. We will never have a curve, never have a curve that wanders randomly. You may wander a bit randomly, but that's just because your data may wander a bit randomly, but that's just because of the lab and things like that. Now, we're going to do some correction here. This first one, has this first one been drawn nicely? Is this a good draw, good line? No. Does this look like a curve or does it look like a straight line? Any guesses as to what shape this is? Yes? It could be exponential. Okay. I'm looking at it and I'm like, it goes slow and then it goes fast and then it goes slow. I'm thinking that's one of those weird sigmoidal ones. Okay. I'm not going to give you one like that on a test because that one's a hard one. Yes? What about number 2? Curve or straight line? Tell your partner, curve or straight line? Curve. So what you do to draw a curve is you just do your best to make it flow through the data. Okay? If you go to university and you need to draw graphs for things like this, you can make Excel figure out what the smooth curve is and draw it for you. Okay, but for grade 9, we're just going to eyeball it. We're going to be like, okay, just make it nice and smooth. All right? And what about this one here? Straight line or curve? Curve. Something like that. So draw those in. And then I'd like you to also do 4, 5, and 6 on your own. Okay?
The first one is a wing, or 4 wings.
So for these ones, the first 3 are up there. So you want those 3 are up there. So you can copy those. I'll make it a little bit smaller so you can see all 3. And then you're going to do the ones on the right-hand side yourself. Okay?
Hey, what is that drawing? Why is it so small? Hey. Hey, that's okay. That's a piece. No, that's a piece.
It is 25 degrees. That's too hot for a costume. 25 degrees. 25 degrees in here. Yesterday, by the end of the day, it was 27 degrees.
So it's 6.
Yeah. 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 It's so good. Yeah, usually cold.
Sigma.
This temperature thing is like, I'm not.
I'm so yes.
Elbow on it. And then see. Okay.
Why so What's wrong with that?
Okay, but it didn't sink in. Okay, that's good. Okay. Dying is okay. You being so is not.
You guys say
What can we do?
ow! I'm not flying something. Okay, that's it. I'm touching your level. I smacked your eyeball, you freaking bum. Why are you so greasy? Why are you so Guess what? Sigma. Why are you so Is that a threat? Yeah. I'm so serious. Sigma. Yo, Nick, why is your neck so red? Oh. Usually is. My neck was red one time, I got back. Actually, my neck is just red. I received
Okay, lovelies, let's go over this real quick, and then we'll talk outliers, and then we're done for the day. Okay? So we should have, now if you're not quite sure how to draw the line, remember you can draw a blobby shape and then cut it in half. Yes? You don't have to draw the blobby shape. You can just draw the line. But if it's helpful, now this one is sigmoidal. I didn't do a very good job there. I would redraw that. You can draw a blobby shape and then cut it in half. And then you would erase the blobby shape. Or you can just eyeball it. You can just look at it and be like, that's about where it goes. And either way is fine. Last thing, outliers. This is also a vocab word. Outliers, shockingly, lie outside, outlier, they lie outside the main data. Okay? Stop. My pen is going crazy. Okay, they lie outside the main data. So let's take a look at this. We have knee diameter versus ankle diameter. So for the most part, as ankle diameter is getting bigger, knee diameter is getting bigger by about the same amount. However, what's up with those 2 points? Somebody just has really, really big knees. Yes? So for their ankle size, you just have a person who their knees, for whatever reason, maybe they've got osteoarthritis, which causes swelling of the joint, right? So maybe that's what's happening here. But these 2 points are what we call outliers, because they lie outside of the main data. Pen, stop being so silly. Main data.
Ow.
These guys lie outside the main data.
so good. I did.
Can you see an outlier in this graph here? If you had to pick one, is it above or below the graph, our outlier? It's below. There it is. There is our, what do we call it? Outlier.
What kind of hip girth?
Hip girth? How far around? Hip diameter.
You're not funny ones.
Okay. I would like you to draw. Actually, we have no time left, so I'm just going to give you the homework. Da-da-ba-ba-ba-ba. I would like you to do page 111.